Hi, and thanks for watching this video about my homebrew computer. And today I'm going to be re-adding Blinkenlights to my machine. So what you see here is obviously the breadboard. You may have seen videos. You might have even seen it in real life. I've exhibited it a few times, and I am going to be exhibiting again in the near future. So what I wanted to do is, it's always fun talking about this mess of wires and how it somehow works to form a homebrew computer, something harking back to the early mid 1980s. Um, but it's quite static, and Blinking Lights just brings it to life. You're able to see maybe what's happening on some of these address lines, some of these signal lines that I've got connected up for ROM and RAM banking. And when the computer's actually working, doing certain things, you can just about detect the lights flashing in a different way or blinking in a different way. And so it isn't just a cosmetic effect like in 1960s sci-fi films. The LEDs would actually be reflecting the state of the bus, and the bus and the other control signals will be reflecting what the machine is actually doing at that time. So let me just quickly show you the LEDs that I'm using. Just picking them up, putting in my hand here. They just got them off eBay, basically. 5mm LEDs with some 270 ohm resistors. That's the pack it came in. I can't remember how much it was, but just a few quid. I mean, like, I don't know, maybe 5 quid. I can't remember now, but nothing big at all. What I've been doing is soldering a few of these LEDs and resistors together. So the negative rail or the ground rail is where the resistors plugging into the ground, and then the long lead is the positive lead. So basically, we can start trying to snoop the bus. So this is what I will do first, which is to add some couple of LEDs onto the address bus here. So let me just pause that while I do it, so you don't have to watch me fiddling about, and then I'll resume. Okay, so I've added a couple of LEDs to address line. Well, let's just count it, shall we? That's 15, 14, 13, 12, and 11. So address line 12 and address line 11. These blue lines are the address bus on the 6502. That's what I've connected it up to. So if we switch that on, I'm just going to turn the machine on now, and I might try and just put a bit of shielding there so you can maybe try and see what happens. Got a blue and a pink LED. Let's switch it on. So you see a sequence, and if I switch that off again and then on again, yeah, so that definitely is a deterministic sequence. And now, of course, the light is fully on. But if I do some commands on the keyboard, I'm going to do a dir. Can you see that the blue LED kind of seems to go off? So let me just do a repeated dir, and see how that looks. Yeah, we can really see that these LEDs are flashing in relation to something that's happening on the machine. So that's good. I've just reset it. Let's switch it off. Now, there are some other lines which I think could be interesting. One of them, or two of them, are the two lines controlling which bank of ROM is being, or RAM rather, is being executed. So this orange and red line actually go to here and here in the address decoding logic. And so let's plug those in and see if we can, again, see some behavior based on what the machine is doing. So I'll just pause that while I plug those LEDs in. Okay, so I'm back, having done a few things actually, rather than make a too long video. So we've got the LEDs here, a yellow one and a green one, which reflects the the ROM bank lines. So the machine normally runs off a 64K ROM, which is here, but only 16K of it is mapped into memory at any one time. And so then I employ bank switching to choose between one of four 16K banks. And these lights will show the address line that's being used on the ROM, so we know which bank is in operation. And over here, the RAM address lines, high address lines, are plugged into this red, and next to it a yellow LED. It's very hard to see, unfortunately. My video camera could be better, but there we go. You think you can see it now. And this reflects the RAM banking situation. So there's 128K of RAM, of which there's a permanent bank, but there's then the other 32K slots can be picked from one of four 32K banks, essentially. So that's what the red and yellow LEDs here will reflect. And then finally, you may be able to see this purple LED here. That's actually attached to the interrupt request line from the video chip. And in the future, and in the past actually, what this has been connected to is actually the clock line of a 4-bit counter, a 74 series 161 device. And that counter then will count 16 from 0 to 15, and I was attaching the output to 4 LEDs, and that gives you this nice streaming counting lights. But right now I've just done this because I can't actually find a 161. So let's do that anyway. Let's switch it all on and let's see what's going on. So firstly, let's just see if we can see anything with the RAM. Sorry, this is the ROM. So the yellow and the green lights here. And you can see that there is some kind of sequence during boot up, as I said before. And then let's look at the address line of the 6502. And it's very clear that while it's booting up, we can see that it's toggling the A13 and A12. So it's clearly going, doing something with its program counter. And then with the RAM, now this is something that I don't see that we do much. I don't do much with, because usually RAM is not used from the banks. It's just one bank that I've always got mapped in. So you don't normally see that happen much. But if I do, we can see that the interrupt line from the video chip is working. But if I was to change screen modes, I'll just do that as a loop. And what you should see is, yeah, you can just see that that started to flash. And the reason why it's flashing is because while I'm changing screen modes, I am interrupting the CPU. Sorry, I'm overriding the CPU interrupt. So I'm disabling any interrupt, which is why this light changes. So let's just do it again. Let's just repeat, change to screen mode 1 until 0, and what we'll see is that this light is flickering because I'm constantly disabling and then enabling interrupts. And if I do a DIR, what we should see is that the ROM banks over here, you can see that there is definitely a focus, a noticeable change on the ROM, because I store all the disk handling routines in a different ROM bank to the mainline terminal and basic interpreter. So there we are. I don't want to go on too long. It's nearly 10 minutes. If I can try and do one thing, would be to load up a PT3 file. And if I do a PT3 load Radiohead Creep, what you should be able to see is that the both the ROM and the RAM, but let's go on the ROM, is definitely focusing on a different bank. Well, actually that didn't work because it didn't like the command. So let's just correct that, and you can hopefully see whilst it's loading. I did it wrong again because I need to, let's do pt load rh creep dot pt3. Right, Radiohead creep, and 1 2 3, and then you could see that the yellow lights come up there. And then if I now initialize, if I do, well, let's just start again on this. So let's go to demos pt3 and then pt load 8000 with the Radiohead creep pt3. And now I know, let's have a look if we can see something happening. Yeah, that's loaded. So you did definitely see some LEDs flicking around. Let's just see if we can initialize the pt3 and whether we can spot anything happen. So you may not be able to hear the background music, but it's playing in the background. And as by doing that, I'm definitely hitting the sound chip regularly, which is this existing LED. And if I switch off the interrupts for the music, you can see the sound chip LED has gone off. So that's it. Thank you for watching this video. It's already gone 11 minutes, so longer than I wanted, but hopefully it gives you an idea of how we can make Blinkenlights actually be more than just blinking. They actually reflect the state of the system. Thank you very much for watching.